So I'm going to fix this thing, it seems. Stick around and find out what I'll do. Welcome to part 7 of the HP 3561A DSA repair. If you haven't been following the playlist, then make sure you check the playlist out. I'll probably stick a link up there, or at the end of the video certainly be a playlist link at the end. It's also on my main page too, so look out for the HP 3561A playlist. In the last episode we determined there's a couple of faults on this particular board. The parts have arrived finally, so I can actually start replacing some parts on this board, and we'll see if that solves the problem. Now, one of these we already kind of eliminated as being a major problem, it's just something wasn't quite right. Also, don't forget to like and subscribe. Over here, that diode right there was measuring off. That's a 3-volt diode. That's what it's listed as in the parts list. We actually lifted it off and checked the part number, and it is indeed a 3-volt diode, but that's measuring at 2.7 volts. It didn't seem to be affecting anything too badly though, so we're going to swap that out for a new one, which is a 3-volt diode. We're going to swap that out, make sure it's all nice and new, and that should be better. The other thing we found, I actually found that during the live stream. I was doing a live stream about this. Later on, after the live stream we finished, I was still working on this, and I found that this part here, this SN7406N, appears to be faulty because the output from that device didn't match the input. It was not driving anything. This chip appears to be bad as well, U404. So I'm going to pull that chip there out as well. We'll see if replacing those two parts resolves the current fault. We don't know, there could be more faults yet, which is another reason you should be subscribing, because there could be more things to look at. So the current fault is the front end control error, which is 1100 when you boot the thing up. So we've already solved the RAM problem. We've gone through that process, checked the power supplies, that sort of stuff. We've done a bit of refurbishment around the place, that sort of stuff. We've done a lot already. And at this stage, these are the final two faults I'm aware of. We'll fix these and see if we get anywhere with it. So the diodes I've got here are not exactly the same diode, but they should be an equivalent basically. It's a 3-volt Zener, 500 milliwatt capability, and that's the same spec as what this one here is. So although it's not exactly the same part, it's equivalent, so it should just work fine. It's not overly critical. I mean, as it is, it's sitting at 2.7 volts and it's still working, but I don't trust it, it's not right, so I want to replace it before it fails completely and causes a problem later on. We'll get that part out. So as I've desoldered this part previously, I don't have to work too hard to get it out, because it's already got fresh solder on it. So CR503 is the part we're looking at here. So I'll desolder that. Okay, part's almost out. So this is the original part here, which is probably too hot to hold now. Oh, that's all right. So HP part number, which is 020945 That's an HP part number. The parts list does actually specify that part number as well. And if you look at a cross reference, it does just cross reference to a 3 volts in a diode, which is basically what this is. This is a BZX79-C3V0. 113. This is what I'm using here. Alright, so we'll drop this one in. I'll be really surprised if there's any issues from using a slightly different diode. It's not a particularly critical function, this one. It's just used to supply voltages to a isolator circuit which goes through transformers. So that this low voltage one here is measuring 0.3 volts down, so 10% down, which is out of spec. Then, you know, that obviously needed addressing. Let's put a bit of flux on this. So I'm going to use my silver solder for this, like I generally do for my test gear. Give it a chance to flow right through to the other side. And that should be good. So I was checking the solder over here, it's flowed through just fine, no issue there. So obviously I need to clean it up. So I've already cut the leads off the other side. So give this a clean. I want this to be as clean as possible, we don't want any garbage laying around. Even if it's only a power supply, it shouldn't be too critical anyway, but I don't like to leave flux on the boards. Long term it's usually not a good thing. I mean, sometimes it doesn't matter, it depends how harsh the flux is. That's that side there done. Let's clean up the side. Now to replace this chip. Now there's two ways of doing this. One is to just desolder the legs and hope for the best and try and lift the chip out, and you can do like things like wheeling the legs and stuff like that and gradually ease it out. The other way is to cut the legs off and do each pin at a time. Sometimes you have to do both because you find you're desoldering all the pins, and you can have problems sometimes getting them to release, especially on these double-sided balls like this, the solder style. And you've got to be really careful not to lift pads off or rip off traces and stuff like that. These are quite fragile boards, so you take a lot of care. So sometimes the safest way is just to cut the legs off. I'm going to try desoldering it in one go first and just wiggle the legs and stuff around and see how we go with that. So what I'm going to do to start with, I'm actually going to put a bit of flux on both sides of the board. It sounds a bit strange, but that's what I'm going to do. So I want to try and get this desoldering to flow right through and get it all off from both sides. Right, so the bit of flux on both sides will help that. Hopefully give a slightly better result. What I'm also going to do is put some fresh solder on this side, and having the flux will probably help to get that to flow through as well. See if I can do this without blocking the camera too much. So I'm going to put a fair bit of heat into this to try and get it to go through the board and get the fresh solder to go through and to wet all the flux, and I'm just trying to do what I can to improve my chances of desoldering this nicely. Now we'll desolder them and see how lucky we get. Okay, so basically I did a 3 technique there, rather than cutting the pins off. What I did is I obviously desoldered it, then I also got some of these little piercing needle things. These are really cool, so it's actually like a hollow tube. You can slide this down over the pin as well, so it makes sure you can go through and actually make sure the through hole is clear. And then I did something which is a little bit risky. I did it really gently, used quite a low heat, is I used my hot air then to heat up the chip, because obviously a bit of solder on the top here still. And I used that to soften the solder that was touching between the top pads here and the legs of the chip here. Just got the rest of that off, and now it's just lifted off. Between those 3 techniques it got the chip out in one piece, because I'd like to actually test it. So now I'm going to clean this up a little bit before I put new flux and everything on. So I want it to be a bit nicer. That's all cleaned up. Let's put in an IC socket. Just like that. We'll tap that in there. Always like to use a socket if I can. This makes replacing a chip again easy next time. Don't have to worry so much about damaging things, right? It makes things a bit safer. Also means that if this chip blows again because of some other fault which I haven't identified yet, I can easily swap it out again without having to go through this and risk damaging the board again. I'm going to use my silver solder again. What I've got to do is take it in place, and then I can do it properly. So let's get some solder on the iron tip here. Take it on there. And over here. Just want to make sure it's held down properly. In there. Okay, it won't go anywhere now. Let's get this soldered up. I'll put some flux down. I'm not sure how many layers are on this board, whether it's got more than 2 layers, like, one each side. It might have internal layers as well, I'm not sure. Right, so here's a brand new part installed in my tester here. This is the one that's just arrived. 7LS06 or 05, it's pretty much, it's not an LS, but it's what it recognises it as. So I'll take that part out, install the one we just took out, do the same test, can't find it. It's a bad part, definitely a bad part. Excellent. Let's drop the part in there. Now I had this IC socket sitting around for a little while, so what I actually might do is pop the part in and out a couple of times and just be sure that it's got a decent connection. Just clean the connections up a little bit. There you go. Right, let's put this thing back together and see if it actually works. Have you got your fingers crossed? Don't forget to click like and subscribe. Let's power up for the first time and see what happens. Now remember, I found this thing's horrendously noisy. Once I get it fixed, I'll be replacing that fan. So if this works now, I'll be replacing the fan now as well, and I'll show you that in the part of the video. Let's power it up. I've got it set so you can see some magic smoke if anything comes out. Doing 98 watts. Hey, we have activity. It might be bloody fixed. There you go, look. It looks like it's actually doing something. Wow, I might have actually fixed this thing. Well, let's put a signal into it. I've just got my BNC hooked up here. It's hooked up to my oscilloscope, which has got an AWG built into it. It's set up to 1 kHz. At 100 millivolts peak to peak. So let's turn this on. What do we get? Hey, look at that. It's getting something. Let's do 5 kHz. Here we go. There's the waveform there. So let's do define start 0.5 kHz. If I do a span of 2 kHz from there. Well, it's definitely doing it alright, isn't it? Look at that. It's bloody working. So let's try changing the frequency. Let's go back to 0 to 100 kHz, looks like. Yep. It's automatically tracking this. So AWG frequency. Let's go 10 kHz. Yeah, well that shifted. Okay. Let's do 100 kHz. Yep, it's right there, right in the end. Alright, let's drop it down to 90. Look at that. It bloody works. Thought I'd just try a different part of the scale. It's done 100 Hz and I'll set it to a 200 Hz span. Here we go. Don't know how to get this bit set up right yet. I don't know how to use it yet, but it's actually working. I'm very happy about that. These errors over here have gone, like the over message that was there before. That's gone. So it's obviously working properly now. So it looks like I've probably solved that problem. Let's do some amplitude checks. Let's do 1 millivolt. Does it handle that? Looks like it has. It's just sorting itself out. Yep, there we go. Getting down the noise there. That's 4 millivolts peak to peak as the lowest my scope will do here. So if I do 1 volt peak to peak, what does that do? There we go. Sort out scaling just fine. Excellent. Time to replace the fan. Let's get this back panel off. Now we've got to do a few things here. Set the fan out. So these studs here all need to come apart because these are part of the fan assembly. These come through it, I think. Okay, slide this off. These have been slightly bent, so it's a bit of a awkward situation getting these off because they're not all straight. So here we've got another metal guard, and this is all bolted through from the other side and stuff as well. So we've got a screw on the top here. It's got to come out. There's one at the bottom as well, and you've got side rail screws that will come out as well. So there's that one there. There's a screw under here somewhere. Can I do it by feel? Come on, do it by feel, Scott. Oh, look at that. Found it. little bracket thing under there too. I think it's like a spacer if I remember rightly. So I did have this apart before when I was doing something. When I pulled it apart to service the fan, that's right. And I found out because I had to straighten the back panel up as well because it's all bent. So that made things a bit more complicated. I stripped the back panel off, not just the fan. So I had to get the fuse assembly out. I did that in a previous episode of this repair. So if you want to see a bit more detail about how to get everything apart, you probably want to see that one. I think it's number 1 or number 2 or something. It might be number 2 actually. Alright, let's slide this off. So, a whole bunch of connections and stuff in here. Here is the fan. So what I might just try and do is pop this off to not risk ripping a cable. That's that one out. These other ones are pretty much fixed in place, you can't do much about them. I need to just readjust myself here on the desk so I can get to the fan. So what it's got in here is like a little fan shroud here to help direct the airflow. I've got to take this off, so I've got to take these 2 screws here out, which will then remove this, which then allows me to get to those screws so I'm going to get the fan assembly out. Now the fan wiring is another matter. It comes along the top here and onto the board over here. So all I've got to do is tack onto that. I'll show you a bit better once I get this apart. So I have to undo these 2 screws here. These will take that little shield off and also part of the housing. All of these screws have got little lock washers on them, so make sure you don't lose those. And don't undo these screws unless you've got the back panel off. Otherwise that shield will fall inside. This is the bit that's going to fall off. So here we've got these little nuts on there, so you've got to take these nuts off and then we can get the fan out. Hand little adjustable spinner. Once they're loose I should be able to spin them off hopefully. Alright. So I've already got some fans here for this. I purchased them ahead of time thinking that I'm going to need them, even if I don't use them for this, I'm going to need them for something. So hopefully they are going to fit okay. Alright, so the nuts off. So I should be able to pull the fan out. And all these screws will be falling out as well. So there's the screws. It's a shame the fan is noisy because it's, you know, they don't make fans like this anymore with a spacer. Now this has actually got a spacer here. Don't lose this spacer. This is actually used on the bottom here where it attaches to the bottom casing. So don't lose this spacer. So when you take the bottom screw out, you have to watch out for this and make sure you put that back in again afterwards. Alright, so there's the fan, and as you can see it's a chunky beastie. And it's soldered onto the board over here. So I need to desolder this, get a new fan, get it mounted up, solder it on. Unfortunately this isn't going to be very easy for you to see, but you can just see the wires attached here. So let's get these off. Don't take the board out because I'm soldering it from the top. Here we go. There's the old fan. Let's get the new one. This one I'm going to put in, one of these Noctua fans, 24 volt, as is the original one. And that should hopefully fit in place. There's got to be rubber boots on there too, which may or may not be helpful in this situation. I'm not actually sure. We have to try and squeeze everything in. It's already got this sleeving on it, which is quite helpful. Just put the wires straight on there, and it should be good, I think. Yeah, I think that'll go quite nicely in there. But also I've got to get the screws through it and everything like that. So I'm going to fiddle around with that and I'll come over. So obviously you've got to make sure it's blown the right way. So you can see from the blade shape, and usually there's arrows. There's also arrows up here. So this is blowing air into the unit, so I have to make sure it's actually doing that. Now we come to my first problem. I can't get the screws in here because obviously these are narrow profile fans. So what I think I'm going to do is drill a hole on this side here bigger, so I get the head of the screw through it. That way it's still basically intact. If I need to I can always put a washer on it and use it for something else. It's a bit of a shame it's set up the way it is because I've actually got some rubber mounts which have been recommended to me for fan mountings. These little rubber strap things, you can actually put them through the fan and use those to hold things onto the chassis. So it's rubber mounting, that way it cuts a lot more of the noise out. But unfortunately, because it's got these filters and stuff on the back here, which is all bolted on, I can't use those in this circumstance, which is a bit of a shame. It would have been nice to do that. This is still going to be way quieter than the original fan, so I'm just going to have to live with that, I'm afraid. But it's got the rubber mounts, so that should help it as well. So I've opened these holes up, here's the reamer, so now we can actually put these in. So what I'm actually about to do is drop this in place. And because it's got these rubbers, it's actually going to basically sit right there. I'm going to be careful about the way this wire comes out actually, 'cause it's going to get trapped, so I need to be careful about that. I might need to make some adjustment to allow for that wire to come out a bit easier. Now I've got the fan mounted in there, I've got the wire sorted out. I was pulled out of the slot which normally runs it around it. So normally there's the wire runs in a little slot in the edge of the fan here, which you can't see right now. And I've just basically pulled out that slot, so instead of going down and coming back up again, it just stays out the front of it. So I'm going to have to make sure I tie this out of the way somehow so it doesn't end up going in the blades, but that's not really a big deal. I'll probably have to gunk it in place or something, maybe some kind of clip or something like that. I'll figure something out. Now you may notice that the bolt is spinning around and is wobbling because it's been bent. So what I might try and do is try and get them all lined up in the same orientation so that it will make it easier to get the cover on and off, because if they're all bent in different directions then it won't necessarily allow you to slide the cover off. I mean, I could risk trying to bend this bolt straight again, but yeah, we'll see how we go with that. It is pretty bent. So I'm going to put all these on. You don't see me do that. Obviously then I've got to do the electrical wiring, but I was going to get mounted up first. Alright, so that's that mounted together. I'll put the shield back on here. Now I can see where the cable's got to go. So I need to do something with this to make sure it's not going to get rubbed or anything like that. It does actually wedge in there quite nicely just like that actually, to be honest. Maybe a gunk it in place so it doesn't move around too much, and just at the end here as well to brace it. That might just be alright actually. I think that'd be okay. The original cable's kind of wedged in there too, so I'll cut it off to length. It's about here somewhere. Because I've got to cut the plug off anyway, so I might as well cut it closer. And then we'll get the wires out that we want. Which is the yellow and black wire. Those are the ones we actually want to have working. Let's cut the sleeve here off. The other ones are sense wires for feedback, and well, in this case we don't care about those. So what you're going to do is just get them and tuck them back inside the sleeve. Of course you don't care. Do that with them. It's probably slightly better for you. Alright, so just tuck them back in there. Yellow and black are the wires you want. Separate those. We'll strip those off, solder them on, then we put it back together. And with a bit of luck it'll actually work. Right, let's just tin these wires, get ready to go in. And I'm out of shot again. Okay, here we go. Let's try and do this. Don't know how much you can see. It's a bit awkward. There you go. They are attached. I also need to do something to make sure this is being strained. That's not a big deal. So what I'm going to do is just gunk these up, put some extra strain relief on these connections, to be less likely to fail if I can get the stuff to come out the tube. Yes, it's messy, but strain relief is always a good thing. And I'll put some down here as well to help secure it down here so it doesn't move around. Just over here where the cable sits in this slot here, I've added something to that to give it something to help hold it in place. And also at the other end here where the wires come across to the fan body, I'm going to put some here as well, just to reinforce it at this point as well. Okay. I like to try and do things, allow for vibration and stuff like that. I might put a glove over here as well. Right, let that dry and I'll come back. Right, let's just turn this back on again. Let's test the fan, see if it actually works. I've only put 2 screws in the back panel just to roughly hold it in place. Oh, that's much better. That's nice and quiet now. Be even better once we've got the casings on it. There we go. Display working. Excellent. That's a massive improvement. Right, I finished putting it back together. Obviously the fan's working. Should actually make sure it's blowing the right way too, shouldn't we? That's not something silly. Easy way of testing that. You get something, you put it over it. Here you go. Got sucked on. It's blowing the right way. So you can see just here, this is where the other screw was, and that's where that spacer's got to go in, because you can see that gap in there. So that is where the spacer goes, is to fill that gap in. So it's a bit fiddly getting in there. So I've got some of these angled tweezers. I'm going to use these to get it in. And then I've got the actual screw that goes in it. So I'll stick the angled tweezers through. And hopefully I can hold on to it long enough. Like this, get the screw in place and pop it in place. There we go. So let's get it started. Don't tighten it yet. Now I'll do all the back screws up. It will get the back panel pulled in, lined up. Then I'll do these top and bottom screws up and we're done. Alright, so I can reassemble it now. Got the shield that goes on there. I'm not going to do any calibration stuff because it's probably fine anyway. There we go. It's been a while since this has been back together. I think the calibration will be right. I mean, I haven't done anything to affect calibration. It's only been digital stuff I've been working on, so should be fine. Don't forget to like and subscribe. So these are the parts got replaced. A 3-volt diode, a SN7406 and a RAM IC, which is, well, this is not actually this one because I cut the legs off it, but it's a HM4864P-3 was what was in there. I put in a -2. It's actually a perfectly good chip, this one, but let's try and demonstrate. And obviously, of course, the big noisy fan. Let's try it again. Alright, let's power it up again. One last test. Right, that fan is so much better. Here we go. It's up and running. Excellent. Don't forget to click like and subscribe if you're not already subscribed. And check out the playlist if you haven't checked out the whole series or any other repairs I do. Go and look at all the other stuff. I've got lots of electronics repairs, test equipment, some general stuff as well, like homeware kind of things, or LED lights, or range hood extractors, that sort of stuff. Loads of different things. Test gear is what I like to do. So here's another piece of test gear which has been rescued, which would otherwise have been thrown away. Well worth the effort. It's a great little piece of test gear. Sure, it's old, but still very usable. I think it gives a thumbs up. And if you're interested in becoming a Patreon, help support the channel, to help me buy more pieces of broken test gear to also fix, then please check out the links down below in the description or at the end of the video where there's a Patreon link about there somewhere. It helps me to buy things. These things aren't cheap to buy. You know, broken test gear like this, it's getting more and more expensive, mainly from shipping perspectives. It's getting harder to get stuff, at least economically, you know, anything economical to repair. You know, it's getting harder and harder to do. So thank you very much to all my existing Patreon supporters and YouTube members who are helping to support the channel and helping to do things like this and do these little projects and rescue pieces of broken test gear. There's a playlist here, something YouTube thinks you should watch. There's a playlist here, which is stuff which I think you should watch, which will be the repair series for this most likely. There's a link here to subscribe to the channel. There's a link there to go to Patreon and help support me. Thanks a lot, catch you later.